Hello everyone, welcome back to the MERN Stack Laboratory series. In the previous experiment, we learned how to import JSON data into MongoDB and perform an absurd operation using Mongo import. In today's experiment, we'll learn how to retrieve data from MongoDB using different query conditions. We'll perform 4 different operations. First, we'll search for a record using a specific name. Second, we'll search using a nested fields. Third, we'll retrieve records whose price lies within a given range. Finally, we'll calculate the total payment using MongoDB's aggregation framework. So let's get started. Before writing queries, let's understand a few important concepts. MongoDB stores data inside documents. A document contains fields. Sometimes a field itself contains another document. Such fields are called nested documents. For example, our data looks like this. Notice that payment contains another field called total. Similarly, transaction contains another field called price. To access nested fields, MongoDB uses dot notation. For example, Payment.Total, Transaction.price. We'll use this notation throughout today's experiment. Let's first insert our sample data. To insert this data in MongoDB, we have the same syntax whatever we have followed for the first experiment. That is MongoDB -db user managed. The database is user managed and the collection is transactions, the same transaction, and the file will be different one. For the first experiment, we use transactions.json. Now we'll use user.json because the file which we are importing is different from the previous one. So we'll import user.json and --JSON array specifies that our data is in array format. So we have imported 3 documents imported successfully. So you can verify it from here. You just have to refresh it, and within the transactions we have 3 new datas. Now we have to open MongoDB shell. It is in this tab. You just have to use the database whatever you have created. Use user managed and then hit enter. This command switches to the database name user managed. If it doesn't exist, MongoDB creates it automatically. Now before executing, we'll start with the first query. Find the record where name is Somu. I have already written the queries here. I have it here. I'll just paste it. Print JSON where within the transactions we are finding one document where name is Somu. You just have to paste the same query here and just hit enter. So the shell will give you the output with the document whose name is Somu. It refers to the current database transactions, which is our collection, and findOne returns only the first matching or document inside the curly braces. We specify the condition name should be equal to Somu. MongoDB searches the collection and returns a matching document. Second, find the record where Payment.Total is 600. So we have the command already written. We just have to copy this and then paste it here. Notice something here. We are using Payment.Total instead of just payment. Why? Because payment is not a normal field, it is nested field. To access fields inside nested documents, MongoDB uses dot notation. So Payment.Total means inside payment. Find the field name total. The query returns the first matching record whose Payment.Total is 600. So the third query, find records where Transaction.price is between 300 and 500. This query returns multiple documents. That's why we are using find instead of findOne. Again, Transaction.price is a nested field. Now let's understand 2 important MongoDB operations. GTE means greater than or equal to. LTE means less than or equal to. So this query retrieves all documents whose price is between 300 and 500, including both the values. Finally, for each, it prints every matching documents one by one. We just have to copy this and paste it here. Whose price is between 300 and 500, it has been printed. So all the transaction.price is 500, it should print. Transaction.price 450, transaction.price 350, it should print. So the fourth query is calculate total payment amount. Now we are introducing a completely new concept. Aggregation is used when we want to perform calculations on multiple documents. For example, finding some average, maximum, minimum, or count. Here Aggregate starts the aggregation pipeline. Inside it we are using group. Since we want only one total, we write id equals to null. That means grouping all documents together. Next, total amount is the output field. Finally, the sum adds all values present inside Payment.Total. After aggregation, we convert the result into an array. Finally, we are just printing the total transaction amount which we have created as a variable. We just have to copy this first and then paste it here, and then the result is inside the total transaction amount. We just have to print total transaction amount. So the total amount is 1900. You can verify it by calculating Payment.Total. So today we learned how to retrieve documents using findOne, how to access nested fields using dot notation, how to filter records using GTE and LTE, and finally how to calculate totals using MongoDB's aggregate framework. That's all for today's experiment. In the next video, we'll move from MongoDB queries to Node.js and Express.js, where we'll learn how to access request headers, work with cookies, and perform basic JavaScript object operations. If you found this video helpful, don't forget to like this video, share it with your classmates, and subscribe to the channel. Thank you for watching, and I'll see you in the next experiment.